Hi everyone. So let me tell you about my project. My project is about examining the growth rate and the fall rate in the foreign exchange rates. So basically, this is a project for my data science capstone project. Uh, so let me tell you the details. So basically, for a particular country, every year there's some growth and fall in its exchange rates. Now I'll be examining those growth and fall rates for this particular country. Thus, I will be able to predict the future exchange rates for that particular country afterwards. Now, I have taken the dataset from the Kaggle.com. The data consists of many countries. For example, uh, for say it's 23 countries to be exact, and 5,712 12 rows. The data is from 2000 to 2019. The data looks like this. For example, thus unnamed is the index. Time series is in the format of year, month, year, day, month. The Australian dollar, as you can see, New Zealand dollar, United Kingdom, pounds, and etc. So when we go on to the next, let's talk about the use case. So my use case is predicting the exchange rate. Now, with supervised training models, I have trained my data set and I will be able to predict the future exchange rates. For example, let's say A be some company which wants to buy some product shares in a country X. Now, before buying shares, it will want to check that that the country X is going to increase in exchange rates or not fall in exchange rates, because when we are going to buy some stocks or shares for from a particular country or a company in a particular country, we will definitely want to check that the currency that we are going to invest in for first is not going to back down, because even if the country stood up but the currency falls, uh, we will definitely have a definite amount of loss in that. So, uh, so that's the use case for this project. And coming on to the next thing, uh, this is the country Japan, and I've predicted the real time Japan's value, Japan's exchange rate value with the predicted exchange rate value. As you can see, the model has been trained completely and has approximately 0.03% of errors. So, how do we reach to this point of the use case? To reach to this point of the use case, I have powered up a Jupyter notebook and created a visualized data for model building, which you can see here. And after the model has been built, we have predicted the data. The model has been built on the TensorFlow Keras library and is using LSTMs as its neural network. Thank you. So before, so next I would like to tell you about the structural representation of the model. So the structural representation of the model or the architecture is based upon the Python. Now, upon the programming language Python, Anaconda is used for the Jupyter notebook. The model is based on the TensorFlow Keras library, as I have already told you, and neural networks are trained on LSTMs. The ETL process showed us that there were 5,702 rows and 24 columns in this data set. Now, after we got the data, we tried to explain the features. So the features weren't given us in the proper form. So what we did was to calculate or to transform them into a presentable form in the model. Then LSTM model has four layers, which is input layer, two LSTM layers, one one dense layer for the output. The activation function is Adam, and the loss function is mean average error. The model evaluation was done on test plus train data and had a really nice rate. Thank you.